This is a pre-built version of the application. So let's start by creating the database that this application will run against. And next, let's go ahead and run the application. And the goal is that given this input data, so the available speakers and the available workshops and rooms and session times, we need to find a schedule with zero conflicts. So we started from generation 0, where this schedule is the fittest one, and it had 4 conflicts. And this is a table representation of that schedule, and those are the 4 conflicts. So we have 3 room booking conflicts, those 3, and 1 speaker in consecutive sessions conflicts. And a conflict can be one of 3 things. For this simple application, it can be a speaker assigned to speak at more than one workshop at the same time, or it can be a room occupied by more than one workshop at the same time, like in those 3, those 2, and this one. Or it can be a speaker assigned to speak in 2 consecutive workshops, like in this one. So we go from generation 0 to generation 20, where we find this schedule with 0 conflicts. And this is a table representation of that schedule. So the solution was found after 20 generations. And this is the solution we found from the workshop perspective. So workshop 1 will be in room 1, and this is the speaker for that workshop, and it will be at this session time, day 1 from 8 to 9, etc. And this is the solution from the session time perspective. So day 1 from 8 to 9, we have those 2 workshops, workshop 01 and 15 in room 1 and room 2, etc. And this is the solution from the room perspective. So room 1 has those workshops scheduled to be run in it, and room 2 has those workshops. And this is the solution from the speaker perspective. So this speaker will be speaking at those workshops. So this one in room 1, this one in room 1, and same this one in room 1. So workshop 01, 08, and 17. And they will be at session time 01, 03, and 13, etc. I will start by creating this folder, which will contain 2 files. So this one where the application logic will be, and this one which will contain this logic that creates and populates this database. So we will have a speaker table with an ID and a name, and this is the data for that, and the workshop table, same with an ID and a name, and a workshop speaker table with a workshop ID and a speaker ID. So for example, this speaker will be speaking at this workshop and this one and this one. And we will have a room table with an ID and a name. So we'll have 2 rooms in this case, and we will have an available session times table with an ID and a time and a previous ID, which will be used to handle speaker in consecutive sessions, conflict type. So we will have, in this case, workshops going on for 2 days. So day 1 and day 2 from 8 to 5 each day, and each session goes on for 1 hour. So let's go ahead and run this, which will create and populate the database. So this database. Now the domain of this application will be made up of a workshop, and this class representing a speaker at the workshop, and this one will represent a room where the workshop can be scheduled. And this will represent the time when the workshop can be scheduled. And this one will represent a specific workshop with a specific session time and speaker and room. Now a workshop will have an ID and a name and a speaker, and those will be initialized in the constructor, and get methods for those, and the toString method will return the name of this workshop. And a speaker will have an ID and a name, and those are initialized in the constructor, and get methods for those, and the toString method will return the name of this speaker. And a room will have an ID and a name, and those are initialized in the constructor, and get methods for those. And a session time will have an ID and a time and a previous ID, and those are initialized in the constructor, and get methods for those. and a session will have an ID and a workshop, and those are initialized in the constructor, and we'll have a speaker and session time and room, and those are set with set methods, and we'll have get methods for all five, and the toString method will return a string containing the workshop ID and the room ID and the speaker ID and the session time ID. And this class will pick up the data from the database. So this database, and here we are doing a select on the room table to pick up the rooms, and on the session times to pick up those, and on the speakers and the workshops. And here we are using the select workshop speakers for each workshop. And here we have get methods to return the rooms, the speakers, the workshops, and the session times, and the number of sessions. Which would be the number of workshops. And this class will handle all the display, so here we will be displaying the input data, so the speaker, the workshop, the room, and the session time data coming from the database. So this one displays the workshop, and this one the speaker, and this the room, and this session times. So let's go ahead and test run, just displaying the input data. Okay, so let's go ahead and import those two, SQLite 3 and pretty table. And now let's try again. So this is the speakers and the workshops and the rooms and the session times. And this class will represent a conflict between two sessions. So we have three types of conflicts: either a speaker booking conflict, or a room booking conflict, or a speaker in consecutive sessions conflict. And in the constructor of this class, we initialize conflict type, so it would be one of those three. and the sessions that this conflict is in between. And we have a get methods for those two, and the toString method will return a string representation of the conflict type and the sessions that this conflict is in between. And we need to import this here, since we're using it here. And this class will represent a schedule and this one a population of schedules. And this will contain the genetic algorithm logic. So crossover, mutation, and elitism. And we will need to import this. Now a schedule will have sessions and conflicts and get methods for those two, and this method initializes all the sessions. So here we're picking up all the workshops, and we're creating a session for each one, and randomly selecting the session time and the room, and appending that created session to this sessions. And this method returns all the session times, IDs, that are associated with a speaker. And this one calculates and returns the fitness for this schedule. So here we are checking if we have a speaker scheduled for consecutive sessions, and if so, we instantiate a conflict of the type speaker in consecutive sessions and append it to the conflicts. And here we have or we are checking for room booking conflict, and if so, we are instantiating a conflict of room booking type, and we are appending it to the conflicts. And same for speaker booking. If we have that, we append it to the conflicts. And if we have zero conflict, this will be 0, so we return 1. for fitness. And this method returns fitness and recalculates it in case it has changed. And finally, we'll have this toString method that returns a string containing all the sessions in this schedule. And a population will have schedules, and we initialize those schedules here given the size of the population, and we have a get method that returns them. And let's update. This display manager class. So we're displaying the schedule from the room perspective, and also displaying the schedule from the speaker perspective, and from the session time perspective, and this displays a generation of schedules, and this one displays the schedule as a table. And this one, it displays the schedule conflicts. And we'll have this function that finds the fittest schedule. So we're instantiating a population, so it'd be generation 0, and we are sorting the schedules in that population and displaying the generation and the schedule as a table and the conflicts, and returning the fittest schedule in that population. And let's suppose we have a population of 12 schedules for each generation, and let's go ahead and call this function to find the fittest schedule in generation 0 before adding the genetic algorithm logic. So this is the input data, and this is generation 0, and the fittest schedule had 5 conflicts, and this is a table representation of that schedule, and those are the 5 conflicts. We have one speaker booking conflict, so this speaker is booked for those 2 workshops, at the same session time. And here we have 3 room booking conflicts. So for example, for this one, we have room 1 booked for 2 workshops, workshop 09 and 10 at the same session time, session time 08. And here we have a speaker in consecutive sessions conflict. So this speaker for this workshop so on day 1 from 4 to 5, and we have this same speaker booked on day 1 from 3 to 4, so 2 consecutive workshops. And let's add the logic here. So this method does crossover on all schedules in the population, and it uses tournament selection in order to select 2 schedules to do crossover on. So this method does the crossover of 2 schedules and returns a crossed over schedule. And this method does mutation on all schedules in the population, and it will end up calling this mutate schedule method for each schedule in the population. And this method does tournament selection. So suppose the tournament selection size is 3, which means it will pick 3 schedules from the population, and here the population size is 12, so 3 out of 12, and it will sort them by fitness, and then pick the one with the highest fitness. And here we define the number of elite schedules to be 3. So we don't do crossover or mutation to the first 3 schedules with the highest fitness. Actually, let's do this. Let's make this to be 1 and make this population size to be 9. And this public method calls crossover population, and what's returned from that we call mutate population on it, and we return the population that was mutated and crossed over. And let's update this function. So now we're evolving the population using the genetic algorithm until we find a schedule in a population with a fitness of 1. So no conflicts. And let's add this code here so that we're displaying the schedule from the workshop perspective and the session time perspective, rooms perspective, and speakers perspective. And finally, let's go ahead and test run the application. So this is the input data, and we started from generation 0, where the fittest schedule had 6 conflicts, and this is a table representation of that schedule. So we had 5 room booking conflicts and 1 speaker booking conflict. So this speaker has those 2 workshops, 10 and 19, at the same session time, 12. So we went from this generation to generation 12, where this schedule had no conflicts, and this is a table representation of that schedule. So we found the solution in 12 generations. And this is the solution from the workshop perspective. So workshop 1 is scheduled on day 2 at this time, and workshop 2, etc. And this is the solution from the session time perspective. So day 1 from 8 to 9, we have those 2 workshops in room 1 and room 2, and etc. So day 1 from 10 to 11, we have this workshop. And this is the solution from the room perspective. So room 1 has those workshops scheduled in it, and room 2 has those workshops. And this is that solution from the speaker perspective. So speaker 01 has those 3 workshops during session time 15, 12, and 04, etc.